Good day, fellow. Setso is back. Today, I just want us to consider this concept of Coulomb's law. Now, the Coulomb's law is given by this formula. F is equals to K, let me say Q1, Q2 divided by R squared. You see? Then now let me just state Coulomb's law using this formula, would say the electrostatic force, electrostatic force, which is this one, is directly proportional. See now, it's directly proportional to the product of charges Q1 and Q2, to the product of charges, and inversely proportional now, inversely proportional to the square of distance between them, and inversely proportional, you see, to the square. The square, we are referring to these two, square of distance between them. You see, this is just a definition of what? Of Coulomb's law. Now what I'm going to do is, let me consider this term, electrostatics. Let me take this term of electrostatic. See, it is made up of two words. We have electro and we also have static. The word electro, it has to do with charges, electric charges. Electric charges. We also have static, at rest. Let me say at rest. Then now, let us define the whole concept of electrostatic. The term, it has to do with the study now. The study of stationary charges. You see, charges. That's a basic definition of electrostatic. Bear in mind that we have three electric charges. We have positive charges, we also we have negative charges, and also those which are neutral charges. You see, neutral charges. Then what do we call those charges which are positively charged? We say they are protons. Let me say proton. Then those are negative, we call them electrons. See, let me say electron. We also have those which are neutral. Then I'm going to say neutron, like this. You see? Then now, let me ask you this question. Suppose now if I have a positive charge together with the positive charge. You see, suppose I decide to bring these two charges close to one another, what is going to happen between these two charges? They will repel each other. You see, they will repel each other. And now if I take a negative charge together with a negative charge, what is going to happen? Same applies. They are going to repel each other as well. Lastly, I have a situation of positive and also negative. Then as for this one, they are going to attract each other. You see? Then now, let us go back to that formula of Coulomb's law. Let me just erase. Okay. We have this formula of F, which is given by K, Q1, and Q2 with R squared, like this. Then we have F, which is our electrostatic force, and it is measured in Newton. You see, we have K, our proportionality constant, which is given by 9 times 10 to the power 9. Then it is measured in Newton, meter squared, C minus 2, like this. Then we also have Q1 and Q2, but I'll just write Q, which is our charge, measured in Coulomb with a C. Then now we also have what? Our distance between two charges. It's R, then it is measured in meters. You see? Then now what I'm going to do is, there are some of the things that you must know regarding charges. You see, regarding charges, let me write here, regarding charges. See, we have a case whereby you'll get something like this. Let's say micro Coulomb, nano Coulomb, and pico Coulomb. And we know that our charges, it has to be in Coulomb. You see? Then for such, for micro, we always multiply by 1 times 10 minus 6. For nano, with 1 times 10 to the power of minus 9. Lastly, pico, 1 times 10 power minus 12. Like this. You must know these things. You see? Now let us move to our distance. It is always measured in meters. But now what is going to happen if, let's say, I have 2 centimeter? To move from 2 centimeter into meter, we are going to divide this number by 100. It's like we are going to say now 2 divided by 100, which is, I know you already have your calculator with you. We get 0.02 meters. See, if let's say we have 2 millimeter, for this one we divide by 1000, like this. Then we are going to get 0.002 meter. You see? Then this one is for distance. It's for distance between two charges. You see? Then now let us use this equation to calculate the value of F. Suppose now if I have this situation. Let's say if they were to give us two charges, let's say if I have a positive charge like this of 4 nanocoulomb, somewhere there I also have what, a positive charge of 3.5 nanocoulomb. Then let's say if they give us the distance between these two charges to be, let me say 0.07 meters. Then with this given information, I ask you now to find or to determine the electrostatic force between the two charges. Firstly, let us try to figure out our data. You see, then now we have our R value, which is already in meters. There is no need for us to work or divide this value. We take it as it is. Then now we have two values, a positive together with a positive. Then now check on this one. Let us make this one to be Q1 to make things to be much simpler. This one is going to be Q2. Then let us take Q1 and say now we have 4. We have to change this nanocoulomb to coulomb. We are going to multiply by minus 9, you see, which is coulomb. You see? Then let us move to the next one, which is Q2, 3.5, where you see this nano multiplied by 9, 10 to the power of minus 9. This is our coulomb meters, you see, like this. Then we know for sure that the value of K will always be 9 multiplied by 10 to the 9. You see? Then let us go and substitute these values. Where on this formula we have F, which is equal to K, Q1, Q2. Then we divide by R squared like this. See? So simple. Then your K value is 9 times 10 to the 9. Will I have enough space? Let me just write anyway. K, we have now Q1, which is 4 times 10 to the power of minus 9. Then our Q2, which is 3.5 times 10 to the power minus 9. We close. Then we divide everything now by 0.07 square. Then let us take our calculator and try to figure out. Okay, we have 9 multiplied by 10 to the 9. Also have 4 times 10 to the power of minus 9 and 3.5 times 10 to the power of minus 9. You see, I'm using a different calculator. Then let me divide by 0.07. Then I have to square this. Let's see, what do we get? I get F to be 2.57 Let me round this one to 1 decimal. Multiply by 10 to the power of minus 5 watt Newton. Now I have two charges which are positive. What is going to happen to these two charges? Since they are positive, somehow they repel each other. You see, this one is going to move to the left and this one is going to move to the right. Just like this, we have managed to do or somehow to solve for this problem of Coulomb's law. I thank you and enjoy.